In this video, we're going to be going over how you can use IoT connectors to work with sound and vibration data. For this example, we have right here a sound data IoT connector. I'm going to go in to show the configuration of this IoT connector. For this IoT connector, we are getting our data from MQTT, and our topic is Sorba Sound Topic Test. Now, the important part here for the data for vibration data and for sound data is a data processor. For this one, we're going to be doing a spectrum or FFT diagram from our waveform data. So the source for this, the data is coming from MQTT, and we are receiving waveform data into Sorba that we're then using a data processor in order to convert into an FFT. Now, if I go into the configuration for this FFT, I have it selected as one-sided, and then you have here different metrics. So we have frequency, amplitude.real, amplitude.img, and amplitude.abs. These are for the different metrics from our FFT. Now, the important part behind this is that if I were to write this data into Sorba, so for instance, this particular IoT connector is actually, as you'll see in a moment, writing from MQT and sending back to MQTT, and we'll be looking at the results through just a plotter. However, if you wanted to, you could write, for instance, MQTT to influx, and then when you're accessing these tags, you would just simply put it to one particular tag, and then you could put in that tag dot frequency or that tag dot amplitude dot real to get these different metrics within influx. All right, I'm going to go ahead and save this data processor. And as I said, our destination for this is going to be back to MQTT. And we'll be writing to the topic sound_FFT. So with that, I'm going to go ahead and actually start my script to send out our source. All right, so what this is actually doing, this script here, it is actually taking the sound data from my laptop speakers, and it is writing that to MQTT. And it is doing that under the topic of Sorba Sound Topic Test. Right. And I actually have here a workflow set up. And we are looking at this sound FFT, which is what that IoT connector is writing to. So on our debug, we can now see that we do actually have the waveform data coming in. And with that, I should be able to go here and run a plotter script. And there we go. We can now see our FFT diagram, and this FFT is being generated from Sorba. So again, essentially, this data is coming from my laptop speakers, being sent to MQTT, and then it is being brought into Sorba with that IoT connector to then be converted into an FFT diagram and being sent back to MQTT, where this plotter script is then reading that information and writing it to this plotter in order to actually get our FFT diagram. Now, there's a few other things that I can do with this with my IoT connectors. So one thing that is common for vibration analysis is to sort your frequency into bins, and then that way you can look at the amplitude of different bins. So if I go back into my IoT connector, I can edit this node. And then let's say that I want to go ahead and add in an extra data processor. So what I'm going to do is I'm going to add in an extra bandpass filter. And here we have the thresholds for it. So if we actually look at our plotter, let's say that we wanted to get the data just between 1000 and 2000 frequency. Just between a frequency of 1000 Hertz and 2000 Hertz. All right, I can go ahead and save this data processor. And actually for the ordering of these, I would want to move that to above my FFT. I can then save this and apply changes, and we will wait just a moment for that to finish applying changes. All right, and there we can see that by applying a bandpass filter between 1000 and 2000, we have actually managed to narrow down the frequency data on our FFT to only include this portion of the FFT. Now, what this means practically within Sorba is that if you were to go back into your IoT connector data and you were to go ahead and bring this into influx instead, for instance, I could use the dot amplitude off of my FFT in order to actually get the amplitude for that particular bin within my spectrum. Now, what this means is I could create IoT connectors for each bin that I want to track the amplitude for, and then bring in that amplitude data for that bin into Sorba in order to then use that for different purposes for analysis, including machine learning, if I wanted to include my vibration data in my machine learning analysis. And that is how you can use Sorba in order to bring sound data into the platform and to generate an FFT for that waveform data by using the data processor's pipeline.